So, so today I'm here to talk about one of our research topics, novel to graph. So straightly diving into the topic. So novel to graph in general, it deals with narrative text understanding, which is a challenging area and with a lot of research dimensions. And our main focus is on literary text understanding, sorry, which is a part of narrative text understanding, which deals specifically with novels, stories, etc. And we focus on modeling the static and dynamic relationships between the characters in the novels. And what was our motivation behind dealing specifically on literary text domain? So one is about the textual content in novels and stories. If you think about it, it has its own inherent complexity, different writing styles, different types of language, uses specialized phrases, neologisms, like they introduce new words. So in general, it's difficult to tackle with such complexity of language. So it's a good benchmark for, in general, for natural language understanding task also. And there were, of course, a lot of linguistic and literature enthusiasts who wanted to learn or who are curious about learning such relationships between the characters involved in the novel, learning both static and dynamic relationships between the characters. So this was some interesting visualizations which we could find online, which people have plotted manually for some of the famous stories like And the Mountains Echoed and Count of Monte Cristo, where they represented it graphically using the characters as the nodes and their relationships with edges, and even tracking some of the sentiments of the characters. So going to our proposed pipeline, so we tried to approach this problem by combining natural language processing techniques, machine learning, and also deep learning approaches. Now, the initial, so first I wanted to tell that the reference for our analysis was the Harry Potter novel series by J.K. Rowling. And we selected Harry Potter because, of course, it is a well-known novel, worldwide known. It has a lot of textual content. It has like 6 series in it. And also in this domain, like in the literary text domain especially, there is lack of annotation. So when we wanted to analyze our results, it's important that we need manual annotators. And there are a lot of Harry Potter enthusiasts who actually, they have special groups where it's easy to find annotators, and even they do it freely sometimes. Okay, so first module here is to detect the characters, because characters are the main entities in our model. So we use the general named entity recognizer by Stanford Core NLP to identify the characters, and we tag the characters as person, and we use merge the recurrent sequences of names into a single character by simple heuristics. So after this, next problem is to deal with dealiasing. So in the novels, you know that a particular character can be referred by different names. So in order to get the major references, we used a clustering technique using TP scan with Levenshtein distance to get the clusters of the characters, for example, like Harry Potter, Harry, H. Potter, etc., which are the different references to the main character, Harry Potter, and then replace them with an identifier. And we also used co-reference resolution from Stanford Core NLP in order to resolve the co-references to the characters. So in the first step, we replace all the possible characters available in the text with the identifiers, with their respective identifiers. Next step is relation identification. So in the initial phase of our research, we started with static relationships. First was to identify the sentiments of the characters and the relationship sentiments. So we wanted to know whether a character is positive or negative in a particular story or a series, and also the relationship between the characters. In order to identify whether a character's role is positive or negative, we extracted the phrases where the character name occurs. And in order to deal with the relationship, we just extracted the sentences in which the characters co-occur, the character names co-occur. And we did a simple sentiment analysis using the universal sentence encoders. This was in the end of 2018, and we published a paper termed NOVEL2GRAPH, Visual Summaries of Narrative Text Enhanced by Machine Learning, in the text-to-story workshop. So this is about the static relationship, and we generated visual summaries or graphs using the outputs of this method. So of course, this is a static graph, and the nodes represent the characters, the edges, the relations between the characters, and the size of the node is like the relative occurrence of the characters in the particular book. And these colors represent the sentiments. So whether the character in that particular series of the book was positive or negative. Positive is represented by blue color and negative by red color. You can also see a dashed line where we implemented a small module to identify the family relationships between the characters, which I will explain shortly after some slides. Okay, now moving into phase 2, we started focusing on temporal embeddings, where we wanted to capture the dynamic relationships or the dynamic evolution of the characters over time. So this type of temporal word embeddings were widely used in the application of semantic shift phrasing in order to understand how a particular word evolves over time period. So for example, you can see the figure where the semantic trajectory of the English word gay is shown over different time stamps. And you can see that in the earlier centuries, it was more related to words like cheerful, courageous, etc. While in the the new century, it's more related to homosexual or lesbian. So it actually tracks, there are methods. So temporal word embeddings could track the change in the semantics of the word across different time periods. For our approach, we used this similar concept in order to study the evolution of the characters over time. For this, our main reference paper was by DiCarlo et al., where they proposed an approach for training temporal word embeddings with respect to a reference corpus. This is required because when we train the embeddings over different time periods, there will be a problem of alignment. We cannot directly compare those embeddings. In order to solve this problem, they proposed an approach to keep a reference corpus based on which the embeddings will be trained. So they used a word-to-vec model, specifically the continuous bag of words model. Initially, a static embedding will be trained by ignoring the time interval. So we have a temporal context embedding matrix and a temporal target embedding matrix. Now, for each time slice, we train the temporal context embedding matrix, but we freeze the target embedding matrix, which is considered as the corpus or reference. And the authors in their paper have shown that this method is simple but so effective in order to solve the alignment issues. So we use the same approach for our method in order to train the static embedding over the different time stamps, which are actually the books. and then to train the temporal embeddings over each time slice, so that we can compare the evolution of the characters over different timestamps. Okay, so the first analysis we did was temporal word analogies, which is one of the most common methods to analyze temporal word embeddings. So this actually measures like what is the semantic role of a particular word at a particular timestamp, and to which other word it is related in another timestamp. So for example, like Ronald Reagan in 1987 is like Bill Clinton in 1997. So the authors show that the words which are related to these two characters or these two entities would be like president, administration, etc. So taking this assumption, actually they propose this model, which I have already explained. So we actually see the alignment of semantic areas between the entities. So in our case, it would be considering, like, for example, Voldemort is one of the main characters in Harry Potter series. So Voldemort in book 1 is associated to which particular character in book 2. So that would be the question. We had to use manual annotators for validations. So we considered each book as a timestamp, and for temporal word analogy, we had to just extract the vector of the character in a particular book and find the vectors which are close to them based on the cosine distances in other books. So this work is also published, and we found that the method helps us to find the analogies, and especially dealing with both static and dynamic analogies. Maybe the character doesn't change, that is termed as static analogy, but dynamic means it refers to another character. Solving dynamic analogies are more difficult compared to static analogies. Okay. So next, going to the analysis 2, we actually plotted the trajectories to see the relationships between the characters. So in this given figure, you see the trajectories which are based on sub-slices, or the time slice is text of length equal to 1,000 text characters. You can decide the time slice, and training the model is quite simple. And we consider here Harry Potter, which is the main character, as the reference, the x-axis, and plot the evolution of another major characters in the book, Hermione, Ron, and Voldemort, based on their relative distances from the Harry Potter. So it is expected that the closeness of the trajectories shows the relationships. So Hermione and Ron are actually friends of Harry, which are closer to Harry. Voldemort is the main villain character, which you can see deflection, or it's moving away from these characters. So these types of studies were done in order to analyze the evolution of the characters' relationship across the time stamps. And as I described, we also implemented a small module for identifying family relationships. In this, we actually try to automatically annotate some data using simple clustering approach. So our method was to see the family relationship. So we use the DB-scan algorithm to cluster the characters under same family. So it's quite simple, because in most cases, their surnames matches. So for example, like Wesley family or Potter family. Then we use the transformer bird-based model in order to train and test the ever approach using this annotated data. And we found that this type of the constructed data helped efficiently to classify the family relations in many cases. So this is one positive note, like maybe we can have some approaches to automatically annotate these types of data. Okay. So in phase 3, we actually plan to create knowledge graphs based on the characters and their relationships, that is to generate the triplets And we thought of this because, to give a wider applicability, because knowledge graphs can have a wider applicability to other fields also. So this is like the starting research on knowledge graphs. So initially we extracted the entities, which are the characters, using the phrase extraction by constituency parsing tree from Stanford Core NLP. So we extracted all the phrases where there is the presence of a character identifier. Then we consider only, okay, so this is the phrases extracted, for example, for different characters. And once the phrases are extracted, we consider only the phrases which include two characters, because we wanted to define a relationship. And we extract the verb phrase and lemmatize them. So in general, we will have different verbs related to two characters. So they can be related by different verbs. So we use sentence transformers to embed them, extract their embeddings, and then use k-means clustering to in order to cluster the verbs to form homogeneous groups and give them relation identifiers to generalize these verb phrases in order to get a generalized representation or a descriptor for the relation or edge descriptor, you can see. So once the verb phrase, once this clustering is done, we have the generalized version of the relations, but still we don't have it unique descriptors which define the relation between the characters, or we actually don't have the triplet. So we need some descriptors. So in order to get the descriptor or the edge descriptor, initially we tried with summarization of the clusters and using birdsum in order to see whether we can obtain some meaningful labels, but it was not so good. The results were not so good. Maybe because the sentences are not so much related and they are actually phrases and not cohesive. So we used a very simple approach, like we just took the verb which has the maximum number of frequency in the cluster. But even though it's a very naive approach, it actually helped us to formulate some of the relations in a nice way. But still, it's important that we need a generalized relationship, like generalized representation of these verb phrases in order to have an actual triplet, like entity relation between the characters. So this is about the edge descriptor, and the entire pipeline is available as a free software in the given link, and this part is also been submitted as a paper. And yeah, moving into this, I'm just showing the snapshots of some of these demos. So this is like the almost all the main characters in Harry Potter series. We selected the characters based on a minimum number of occurrences, and you can see the edges and the notes. The notes represent the characters, and you can click on a character and see to which particular other characters it has the relationship. And the strength of the thickness of the edge represents the relationship, the strength of the relationship between the characters. And you can also see other details like the aliases that we have found, and the non-relation clustering details like the phrases we have extracted with respect to each character. And again, about the relation graph, which means what are the sentences we extracted and what were the verb descriptors that we have chosen between the characters. So yeah, this is about one of the main output from the knowledge graph, the phase 3. And in this link also you have the option to view the temporal embeddings or the dynamic trajectories also. Okay. So these are some of the main research directions that we took for literary text understanding. still there are a lot of dimensions to explore. We started off with static and dynamic evolution of the characters and methods to model their relationships. And we also extended the approach to build a simple knowledge graph. And of course, in future, the first step is to improve the representation of knowledge graph, especially the edge descriptors, which we also think it's a naive approach to see the frequencies. We wanted to consider some other generalized approaches, which we are working on. We also wanted to explore this approach on a wider range of book corpus and to study the applicability on other books also, like, and maybe could be extended to other domains also. So yeah, that's all from my part. Thank you, and welcome questions or any other points which we can include in future.
Thank you very much for your very interesting contribution. I already have one question on the chat. It's from Simone Grieser. She asked the same question as I would ask. She says, thank you for your presentation. What industry or real-world application cases can you see for this research? Okay, so yeah, one point is it would be, I mean, this particular topic, it's more interested, of course, to the people belonging into linguistic domain or literature domain. Actually, this topic, this idea actually started off when one of the person in the linguistic department discussed to us whether there is a scope of applying NLP or the new deep learning techniques in dealing with literary text. So that's what that's when this complete idea started off. And but in general, I could say that all these applications, like all these approaches that we have used, like for example, entity extraction or relation identification, can be easily extended to other fields. Maybe for other fields, there should be like specific named entity recognizer. In those aspects, it could change, but the general approach can be extended. And again, when you see about the temporal word embeddings or the dynamic evolutions, it's very nice to see the changes in or the trends in where the words or the usage changes across the time. So I think maybe these are some of the applications I could think of. Yeah. Mm-hmm. I see there coming some questions. I have one. Is it also thought that such an application can be used in schools?
Yeah, maybe like for visualizations and all. I mean, always in schools and all. Yeah, it's a good point. Like stories and all, if it's plotted, it could be nice to see the visualizations obtained. And yeah, it gives actually a complete outline of the story. So yeah, it would be a nice application.
Okay, thank you. There is Don Tuckener who asks, how do you evaluate the extracted knowledge graph? And what sort of literature research questions can such an approach tackle?
Mm-hmm. Yeah, nice question. So as I told, we have to evaluate it manually. So we asked some of our colleagues and other people. I told that there is a group of Harry Potter group like that are where they collaborate, like reading and all. So we evaluated it manually, not on any particular standard metrics or something. And of course, this question arises a lot also, especially when we presented the papers. And we have to see, yeah, because you see in this domain, annotation of data is quite challenging. So yeah, either we have to take a lot of time in annotating the data, spending time on that. And for knowledge graph, actually, the idea was to, model these relationships in a more general way, like not like simple graphical visualization. We wanted to get it in a triplet format, which is like a more standard way to approach such problem dealing with relationships.
Okay, there's also Claudia Schulz. She thanks you for the talk and asks how severe is the impact of error propagation, aggregation throughout the pipeline?
Yeah, of course, when it is a sequential pipelined approach, there will be error propagation, but here in each phase, like for example, in character identification, once we identify the characters, we are just using those particular phrases or sentences for the next phase. So it depends. There will be a question of recall, like how many characters were actually identified correctly in this. From the total, but yeah, still this was the simplest way to go on because we could not have a joint approach of relation extraction and entity recognition like we have in another fields which have a lot of annotated data, or at least some annotated data, like in shared task or something. So we have to cope up with this, and of course there is no specific metric that I can show you or accuracy that I can show you, because most of them is manually annotated. So like we had like 15 annotators, and we have to rely upon those annotators.
Okay, it's just arrived a new question from Ivan. Many thanks for the talk, very interesting. Please, could you sketch new possibilities you have in mind for calculating the graph edges?
Okay, so one of the possibility that we are exploring is about the WordNet supersenses. I don't know whether you have heard about it. So there is like a supersense concept in WordNet, which helps us to generalize the meanings of the word. So we are working on it. We are in like just the starting phase of it. We have to see whether it actually gives us some meaningful results.
Okay, I have myself another question. I suppose some of the writers will have their own representation, maybe even graphically, of their characters and the relations to others. Did you ever thought to compare the writer's ideas, concrete or maybe even only in his head, with your results?
Not yet, but yeah, I mean, we were actually not aware about such a situation, like we didn't see those aspects, but it's a good point. If writers have such a view, it would be more reliable to compare them with our graphs or outputs. Thank you.
Okay. Thank you.